There's my screen. Okay, so one person said, what's spring break? Another person said, well, we have a quiz over spring break. Somebody's going to Florida, which I'm going with them, and someone doesn't care. Let's see. Spring break is where we don't have a week of co-op. I don't know if your parents do that spring break for you as well. Or if your spring break was you guys being sick, that would be a bummer. Let's see. Mackenzie's going to Florida, so I'm going to pack myself in her bag. That sounds lovely. And well, we have a quiz over spring break. So we have 3 sections left, right? That I was kind of looking at this. So it's kind of up to you. I mean, I don't think you necessarily want to save this section until after spring break, especially if you're going away somewhere fun. So we're going to see how far we can get today. I'm hoping like we'll finish everything by Monday, and then next Friday we can just leave for kind of an open, any questions, or there is one actually legitimately fun project. Okay, let me take a step back. What I'm thinking for the rest of the schedule till spring break. So spring break is on the 17th. Is that right? We have 3 sections left. So I'd like to get through like 1.5 today and maybe 1.5 on Monday. Maybe we can even get through 2 today and 1 on Monday, something like that. Okay. Then I will give you guys your quiz over chapter 5 because it's only 5 sections. Okay. And what I was thinking is that on Friday online, next Friday online, we're going to have like kind of a group project discussion about how many different combinations of Chipotle we could come up with. And if you participate in that, chapter 5, chapter 10, there's only 5 sections in chapter 10. So if you participate in that, I'm thinking you automatically get like a 50 points on your test, and then the rest of the test is only worth 50 points. Does that make sense? So you kind of already get half of your grade is perfect. And sure, we could get Chipotle. Now, if you're like Mackenzie and you're going to Florida, that's completely understandable, and we'll work something else out for you, Mackenzie. Wait, what? I know that was confusing. So, in conclusion, my plan is get through 10.3 and hopefully part of 10.4 today. Finish up 10.4 and 10.5 on Monday. Send out your quiz. Next Friday, we'll have like a online discussion. So we'll kind of all go through this together, kind of a process of using the math that we just learned to do something in the real life, important things. And then that will count as half of your chapter 10 test grade if you participate. So Elijah, chapter 10.2 we did on Monday. Thanks, Daniel. And it's we kind of intermixed it with 10.1. So 10.2 is when you do combinations instead of permutations. So that's a good intro to, or a good review, I guess. So if you remember, permutations means picky. So that's when you're picky about the order of something. Like, so you have 8 books and you want to arrange them, arrange 5 of them in a certain order. Yes, there's only 3 through 9 in chapter and 10.2, so easy peasy, right? And really it's a plug-in kind of thing. But I just want you to know that you can use this. I feel like I'm talking all over the place. So the formula we use for permutations, as I'm scrolling, is up here. It's n factorial over n minus r factorial. So n is the number of objects and r is the number of objects that you take from that. Okay. And there's another way we can write permutations, and it's like this, where this first number represents the n, the number of objects, and the second number represents r, the subset that you're pulling away. Okay. And so then 10-2 was when we were talking about combinations. So combinations is when we don't care about the order. So this would be like if you're picking lottery numbers, right? So say you have, there's a lottery and there's 1 through 60 numbers, okay? And you're gonna pick 5 numbers out of that. So in order to find out how many different combinations of those 5 numbers, we don't care if you pick 2 first and 5 second, or you pick 5 first and 2 second. The lottery, it doesn't matter, right? You're just gonna pick a random set of 5 numbers. It doesn't matter what order they're in. So in order to, if we had a lottery, 1 through 60 numbers, and we're gonna pick 5 numbers out of that, we wanna find out how many different combinations of numbers. We would use this formula here. So we would say there's 60 numbers to pick from, right? And we're gonna pick 5 of those numbers. Now this is gonna be really, really big. Should we do it really fast on Desmos? Desmos, where are you? Okay, so I'm going to go in here under functions and under statistics, and here it is, the NCR, right? So we have 60 numbers that we're picking from, and we're picking a set of 5. So there are 5,460,512 possibilities for numbers we could pick. That is a lot of numbers, combinations. Okay. But if you look at the homework at 10-2, it's really easy. Super easy. Okay, so now on to 10-3 and 10-4. So what we're going to kind of move into now. Oh yeah, you can use that function. You can also do the numbers, right? There is a formula for it. So you could plug in 60 factorial divided by 5 factorial times 55 factorial. And you would get the same thing. All right, so 10-3, we're going to talk about probability. Okay, so yes, you did, Elijah. So probability is talking about the theoretical probability is talking about the event, if an event is likely to occur or not. Okay, so we use P to represent probability. Finally, something that kind of makes sense, right? The probability that something's going to occur. Now, probability in Algebra 2 is going to be expressed as a number between 0 and 1. So you're pretty much always going to have a decimal. Okay. Now, this kind of takes us back to a little bit to other parts of math. A lot of times when you'll hear people talking about probability, they'll use percents, like, oh, there's a 50% chance that's going to happen. There's, 75% chance that that's going to happen. And again, that gets back to just like discounts at stores and all that kind of thing. We can use percents to express things, right? But when we're talking about actual doing the math, we put it in decimal form. So that's what I mean by probability is always going to be between 0 and 1. And that corresponds to the probability being between 0% and 100%. Because remember, if you have 0.5 as a decimal, that's 50%. All right. No, that's not that bad, right? There's this little chart here. This is, you guys are going to be like, oh, yeah, okay, got it, right? If something is impossible, then it has a probability of 0. There is no chance it's going to happen, right? If something is definitely going to happen, there's no other chance, we have a probability of 1 or 100%, right? If we have an even chance, right, it's right here in the middle. So this is at 0.5 or 50% chance. So when you flip a coin, the probability you're going to get heads or tails, the probability you'll get heads is 50%, right? It's 50-50. Unless you have a weighted coin, it's exactly the same. Okay. All right, down here we have the roll of a die, die, however you like to say it, right? So what is the probability that I'll roll a 1? Well, there's 6 sides, right? And there's only one side that has a 1 on it. So my probability of rolling a 1 on my dice is a 1 in 6 chance. So that's about, what is that? 0.125 or 12.5%. Okay. Yeah, good so far? Okay. Down here we have 5 balls. What's the probability that I'll pick a blue ball out of these? Well, 4 of the 5 are blue. So my probability is I have a 4 in 5 chance, or I have a 0.8 or 80% chance. So what I was doing there is I was kind of saying this verbally, but you guys understand this, right? So the definition is that the probability is the number of favorable outcomes over the total number of outcomes. So in the case of these balls, right, I want to know what's the probability that I'll get a blue ball. So there's 4 blue balls out of 5 possibilities. Right? So you get 4/5, and if you change that into a fraction, a decimal, you get 0.8. Okay? I do not like my examples on here except for this example. So I have better examples that correspond, Daniel, you'll appreciate this, to the actual homework problems. But we can do this example, okay? So here's one example that we can actually see. It's actually solved for us. What is the probability to find? What is the probability you would find a family with 2 boys among, this is worded really weird. What is the probability you would find a family with 2 boys among all the families having 3 children? So if you look at all families having 3 children, what is the probability that they'll have 2 boys and 1 girl? Yeah, that's worded weird, Elijah. This, I don't know. I fixed my notes on my personal paper, but I didn't fix them on here. Yeah. All right, so we're looking at a family of 3 children. What is the probability basically they'll have 2 girls and 1 boy? No, I just said that wrong. 2 boys and 1 girl. Flustering me, right? Infinity. No, that's the total number. So we're going from, yeah, it is written wrong. We're going from sections 10.1 and 10.2. We were talking about like the total number of possibilities, right? And in 10.3, we're talking about what is the probability within that group of numbers. Okay? So if you randomly meet a family with 3 children, what is the probability that those 3 children are going to be 2 boys and 1 girl? So what we can do is say, all right, well, how many total outcomes are there? So they could have 3 boys. This is boy, 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 right? They could have a boy, and a girl, a boy, a girl, and a boy, girl, 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 girl. I have all the combinations here. So how many different combinations do we have? Actually, this would be a permutation because we care about the order. How many different permutations do we have of boys and girls? we have 8 permutations, right? Yes, does that make sense? Not 8 factorial, just 8 permutations, right? 8 different ways that we can combine 3. Sorry, nice try, Elijah. Okay. How many of these outcomes have just 2 boys? So we have a boy, and a girl. We have a boy, a girl, and a boy. And we have a girl, a boy, and a boy. So 3, right? So that means that the probability we have a family of 2 boys is 3 out of 8, or 37.5%, right? So what's the probability of finding a family with 3 boys? You're meaning a random family of 3 kids. What's the probability of finding a family that only has 3 boys? Well, that's if they have 2 boys, right? There's only one combination that has 3 boys, right? So the probability of finding a family that has 3 boys is, so probability of 3 boys is 1/8, right? And the same thing, the probability of finding a family with 3 girls would be 1/8. So that's the excitement of that. Any questions? Does that make sense? Okay. So now here's where we switch to the examples that are actually from your homework and not these examples that I have on here. All right, so here's the first one. All right, so I'm just going to read this. This is just like from your book, page 701. We're on page 701 from your book. That's awesome. Okay, you have an equally likely chance of choosing any integer from 1 to 50. So let's just make this fun and pretend like we have like bingo balls, you know, like the bingo hopper, and there's the numbers 1 through 50 in there. Okay, find the probability of each given event. So what is the probability that a number less than 35 is chosen? Okay, so what we want to find is the probability of number less than 35. Okay, so what do you guys think? So probability is the number of favorable outcomes over the total number of outcomes, right? Daniel came out strong, said 70%. All right. So what is our total number of outcomes? How many total numbers do we have to pick from? 50, right? Nice, Daniel. So we have 50 different numbers that we're picking from, right? Yeah? Okay, so what is the probability that we choose a number that's less than 35? So basically, a number less than 35 would be, you guys are so close, a number less than 35 would be the numbers between 1 and 34, right? Because if we pick 35, it's not less than 35. So really, we're saying that we want to know what is the probability we'll pick numbers 1 through 34. So a favorable outcome, there's 34 favorable outcomes, right? Yeah, you totally know that. You were not testing me at all. Uh, Definitely not testing me. Daniel says 0 is a number. True. However, the book, which I do not have typed up on here, says that you're choosing an integer between 0 or not 0, between 1 and 50. So they've excluded 0. But I like how you're thinking. If 0 was in there, then yes. We'll just call it my error for not writing there. So the probability of picking a number that's less than 35 would be 0.68, if I can write. Cyber chase. Or 68%. So would you say you have a good chance of picking a number that is less than 35? Well, you have better than 50-50, right? All right. So same deal. What is the probability? So you have your numbers 1 through 50, right? What is the probability that a prime number is chosen? We want to know the probability. We have numbers 1 through 50. We want to know the probability that a prime number is chosen. Probability prime number. So what are my total number of outcomes? So remember, probability is the number of favorable outcomes over the total number of outcomes. So 50 total outcomes again, right? Because we have the numbers 1 through 50. You guys remember what a prime number is? Nope. Okay, so a prime number is a number that can only be divided by 1 and itself. So if you completely forget that, you could look up in your book. Let's see. Selfish. Yes, they're very selective. They won't be divided by anything else. We know the first few primes, right? 1, 3, 5, 7, 11, 13, but I don't know my higher prime numbers. So the first thing you could do, well, you guys would probably just look it up on your phone, but I'm going to look it up in my book. I gotta have prime numbers listed somewhere, right? 978. So if you have your book, maybe they're all listed out for you. Did I say 978? All right, fine. I'm going to do it the internet way. Okay. Prime numbers, not prime rib, prime numbers. Here we go. Prime number has more, when a number has more than two factors, it's called a composite number. Here are the first few prime numbers. So prime numbers, it's not a cheater alert, right? We got to figure out how many prime numbers we got. I know you guys are going to Google it instead of looking at your book anyway, so I'm just showing you real world, right? So here are our first few prime numbers. 2, 3, 5, 7, 11, 13, 17, 19, 23, right? So we are talking about the set of numbers that go from 1 to 50. So we don't care about any numbers off of that after that. So let's copy this. Let's paste it over here. Oh, it's not going to work. There you go. Thank you. You're counting for me. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 15 prime numbers between 1 and 50. So back to here, what is the probability that a prime number is picked? So the probability a prime number is picked would be, there's 15 positive outcomes of getting a prime number. So 15 out of 50, right? Which works out to be 0.3 or 30%. So what would the probability of a composite number or non-prime number be? Are there 15 primes and 34? Not sure. So the probability of a composite number, right, would be 70%. It would be the opposite probability of a prime number. I'm not sure where the 34 came from. The 34 had to do with a number less than 34. Those are two different problems. You guys are tired today, aren't you? Okay, so that is like in your book, problems 3 through 9. You've got numbers 1 through 50, and you've got different opposite of 30 is a negative 30. So the probability of having a composite number, right? There's 50 possibilities. We said there was 15 prime numbers, right? So that means that there are how many non-prime numbers? That means there's 35 non-prime numbers. All has to do with 1, how you count 1, if you count it as composite or prime. Yes, that's true. We're going to talk about that in the next section. Okay, so the next set of problems is 11 through 15, and I think this is actually even easier to understand. Okay, we're going to have a deck of cards. Okay, there's, not including the jokers, just the standard deck, 52 cards, right? Ace through king. So what is the probability that we would draw a king, a deck of cards? So what is the probability, following book, that we would draw a king. There we go. Daniel's awake. So we're looking for probability of drawing a king. Okay, so there's 52 cards in a deck, a standard deck of 52 cards. There's 4 kings. Right? So that works out to be, you don't like the card ones? So you basically have a 0.075. So you have a 7.5% chance of drawing a king. All right, well, you might want to get out your deck of cards for problems 11 through 15. What is the probability that you would draw a black card? So there's red cards and black cards. What's the probability you would draw a black card? Yeah, there's 52 cards, right? Half of the deck is black and half the deck is red. So the probability you would draw a black card is 26 out of 52, 0.5 or 50-50%, right? All right, here's the tricky one. What's the probability you would draw a face card, which they consider a king, queen, or jack? So there's 52 cards, right? They're saying basically you've got a king, a queen, or a jack. So there's 4 kings in a deck, 4 queens in a deck, and 4 jacks. So Daniel says correctly, there's a 12 out of 52 chance that you would draw a king, queen, or jack. Elijah, you are actually giving me an intro to the next section. So basically a 22.6% chance. I know. Some people love probability and all this, and some people are like, eh. Okay, next example. Okay. Again, straight from your book. This is on page 702. You randomly choose a marble from a bag. Okay. There are 10 black, 8 red, 4 white, and 6 blue marbles. Not the marble problems. Yes, the marble problems, right? What is the favor of choosing white? So we didn't quite talk about this yet. But a favor means that what is the probability that it's going to be successful to draw a white? Okay, so when you see these words in numbers 20 through 23, so you're only going to have to do 2 problems of them, right? You guys are cracking me up. When you say in favor of choosing white, what do you think that means? What is the probability you're going to choose white, right? Out of all these marbles. So we have 10 black marbles. We have 8 red. I feel like I should color code these. We have 4 white. I can't write today. And we have 6 blue. See, I can tell this section is clicking with Daniel. The book does kind of show you, yes. Sort of. I would also listen to this. All of these, we're doing examples from all of these. I know, Elijah. Like I said, this section either clicks with you or doesn't. Okay, so what is the in favor of choosing a white, what are the odds in favor of choosing a white marble? Okay. You're cracking me up, Elijah. So what do you think? This one's a little bit different. Sorry, Elijah's cracking me up. Okay, so what do we think here? This is a little bit different. Odds are a little bit different than probability. Okay? So probability is when we have, and my paper actually has this on here. So probability is when you have the total number of favorable outcomes over the total number of outcomes. All right? Odds are a little bit different. If you're looking at the odds that in favor of an event, you're talking about the probability of success over the probability of failure. Okay, so odds and probability are slightly different. Can you see what the difference between the two is? Okay, so in probability, right, we have our favorable outcomes over our total outcomes. When you talk about odds, and I don't know a lot about odds, but they're important for betting. I know that, right? Your odds are the probability of basically favorable to basically failure. So instead of out of total, this is where the difference comes in. Your denominator changes to, instead of out of total possibilities, it's basically the ratio of success to failure. That's your odds in favor. If your odds are against, you do your ratio of failure to success. Okay, so let's go back to this problem here with random marks on here. Okay, so we want to know what are my odds in favor of choosing a white marble? Okay, so we want to know what is the success, basically the yep, Daniel, you got it. We basically want to know the probability of success over the probability of failure. So can you guys see the difference between odds and probability? All right, so what is the probability we would have success in getting a white marble? Well, here's all our marbles, right? 4. Okay. What is the probability that we fail? The probability we fail is that we pick black, or we pick red, or we pick blue. So we have 4, and then if we add this up out of 24. So the odds that we are in favor of choosing white is 4 out of 24. If I just wanted to know just the probability of picking white, okay, the probability of picking white would be 4, and then my total number of outcomes would be 28. So the probability of picking white is 4 out of 28. Okay. The odds that were in favor of choosing a white are 4 and 24. I'm sure there's a bigger lesson here that has to do with betting, but I have nothing about betting, so I do not encourage that or any of that. But odds are slightly different than probability. Yes, may the odds forever be in your favor. So in the Hunger Games, she was talking about odds, not probability. So which one's a better number? Your odds are actually odds are not probability. You're expressing something. Are you better off saying the probability that you're going to pick a white marble or the odds that you'll pick a white marble? Because your odds are 16.6%, right? Your probability is 14%. Yeah. So odds seem much more, what's the word? Positive. Are we having fun yet? Daniel is. He's like, I like this section. Okay. What about the odds against choosing red? So I'm going to leave this up here. This is how I'm going to, my fancy way of erasing. There we go. Did you say easy to this? So the odds of something bad happen, right? The odds against something red. So when you have against, you're going to do the probability. Let's see. I need to change my color back to black. There we go. When you have against, the odds are the probability of failing over the probability of success. Right? Elijah, you got that one right. Greta and Mackenzie, are you guys still here? All right. So basically, what's the probability that you're going to fail at choosing red? So you're going to fail at choosing red if you get one of the 10 black ones, one of the 4 white ones, or one of the 6 blue ones. Okay? You're going to be successful at choosing red if you pick one of the 8 red ones. So 20 out of 8. So your odds against picking a red are 20 out of 8. I don't even know where you went, Elijah. All right, so the last one is actually on your paper, and it's like problem number 17. I just want to show you this. And 17 has worked out solutions too, but I just want to show you guys this kind of how they kind of combine together. Okay. So it's actually this practice problem. In a lottery game, each person chooses 7 different numbers from 1 to 58. With one lotto ticket, What is the probability of winning the prize? I know, this section is about gambling, sorry. There's all the good probability has to do with gambling. All right, so the probability that you have a winning lotto ticket, okay? Winning ticket, right? All right, let's not get all political. Okay, so how many positive outcomes do you have? Okay, so we have two things, right? We've got the top and the bottom. The top is the total number of favorable outcomes. So you only have one lotto ticket. So you have one favorable outcome, right? That's it. You got one shot at this. Okay. I like the question that you asked, Daniel. Do we care about the order when we pick lottery numbers? So actually you don't. So when they pick the lotto tickets, if you ever, I don't know, have the new, whatever, they pick lotto tickets live. They have the balls bouncing around and then they pull out the numbers. The numbers come out in a random order. And then when they post them, they put them in numeric order from lowest to highest. But they don't really care if you pick 52 first and 3 second, or 3 first and 52 second, right? So we don't really care. So how many different combinations of lottery numbers are there? If there's 7 numbers and they could be 1 through 58. So we don't care, so we're going to use combinations, right? So there's 58 total numbers that I'm picking from. And they're picking 7 out of that 58. So the probability you have a winning ticket is 1 out of the total number of combinations of lottery tickets that we have. Do you think this is going to be a really big number or a really small number? All right, so there's 58 numbers, and we're picking 7 of them. So the probability that you are going to have a winning ticket is minuscule, right? 3.3 times 10 to the negative 9th. You guys remember your scientific notation? That means that your probability of picking a winning lottery ticket is, is 0.1, 2, 3, 4, 5, 6, 7, 8, 3, 3. That's your decimal probability, right? Your percentage is that percentage. So let's say that you're like, this is like the $70 million jackpot or whatever. Okay. And you go around and you buy, I don't even know. Let's say if you buy 1,000 tickets, does that even really put a dent in it? Your odds are still tiny, even if you have 1,000 lottery tickets. Let's go for 10,000, 100,000, million tickets. Even at 1,000,000 tickets, you have less than a 1% chance of winning that particular lotto. Craziness, right? Yeah. Now you can impress your family with your lotto knowledge. Yeah, so kids don't play the lottery unless it's just for fun, right? Lesson of the day. All right, we literally have like 5 minutes left. So I don't know if we're going to get how much we're going to get through of 10-4, but let me give you a 2-minute sneak peek because the one is actually pretty easy. Okay, so I think this is what Elijah was alluding to earlier. Nice, Greta. You can play the lottery if it's just for fun, right? But your odds are not that great. So what happens if you have, and I think Elijah said this, if you have more than one event? So what is the probability if you're picking a card from a deck of 52 cards, back again, Elijah, right? What is the probability of selecting an ace or an 8? Okay, so what we're talking about is that we want to know, you're not doing these, you're just giving up. You're like, I'll just take whatever grade I get in this section. All right, so in a deck of cards, do an ace and an 8, do they overlap at all? Can you have aces and 8? Like, is there a card that's an ace and an 8? No, right? Aces are on their own and 8s are on their own. So we call these mutually exclusive events in probability, right? So what is the probability? We're trying to find out the probability of an ace or the probability of an 8. Probability of an ace or an 8. So what we can do is we can just add up the two probabilities. We can say what's the probability of getting an ace and what's the probability of getting an 8. So the probability of getting an ace is 4 out of 52, right? And the probability of getting an 8 is also 4 out of 52. So the probability of getting an ace or an 8 is just 8 out of 52. Right? Does that make sense? That's pretty easy, right? Okay. So here's where it gets a little trickier, and we'll talk more about this on Monday, but just kind of think about this. What is the probability of selecting a 10 or a diamond? So this is where there is some overlap. Okay, there's 4 10s, and there are 13 diamonds, right? But there's 1 10 of diamonds. So we have to, this is called, so the first one was mutually exclusive, right? They're completely different. This one is called inclusive because there's a little bit of overlap, and we're going to bust out the Venn diagram and everything, right? So we have 10s, right? Or we have a 10s. How many 10 cards are there? There's 4 different 10 cards, right? And then we have diamond cards, and there's 13 different diamond cards, right? How many 10 of diamonds are there? There's only 1 10 of diamond, right? That overlaps. So the probability of selecting a 10 or a diamond, what we do is we say the probability of a 10 plus the probability of a diamond minus the probability of a 10 of diamonds because we double counted it. All right, so the probability of selecting a 10 or of a diamond would be, we have a 4 out of 52 chance of a 10. We have a 13 out of 52 chance of a diamond, and we have 1 out of 52 cards overlaps. So the probability would be 16 out of 52. And we have 1 minute left. All right, so we'll keep going on 10-4 on Monday. 10-4, 10-5, we'll wrap it up. And like I said, I really like to get this more fun project in and count that as part of your test grade. And just for participating, right? So Daniel, you have fun with this section. I know that you're excited about it, right? Cool. All right, thanks for hanging in there today. Sorry. I did, Daniel. Thank you. Oh, let me turn off my recording here.